Hi, welcome to McClutchy Maths. My name is Natalie McClutchy and this is our fourth part of a four-part series on annuities, and we're looking at something special today called a perpetuity. By the end of this video you'll understand how to calculate a perpetuity with a formula and you'll know what a perpetuity is. So let's get straight into it. A perpetuity is a special type of annuity where the amount invested pays out a regular payment indefinitely. Now the word perpetuity comes from the word perpetual, which means to continue forever. So if you think about it, we've got a large amount of money usually and it's invested in a special kind of account, and the interest that earns pays out somebody. And there's some different kinds of examples where we would see that in real life. For example, a scholarship fund or a bursary fund. They're both similar kinds of things. They are monetary awards that enable somebody to attend university or school. So a large amount of money might have been invested, by a bank, for example, $1 million say, and that $1 million doesn't actually reduce in size over time. It just earns interest, and the interest that it earns pays somebody else some sort of regular income. Fun fact, scholarships are usually awarded based on excellence, whether that's academic excellence, musical excellence, sporting excellence, whereas a bursary is awarded to somebody based on their need. It might be because they are from a minority sector in the community or that they're experiencing some sort of difficulty paying for university or school. So that's what the words mean, why they're different. It's not really important to know that for general maths, but you might see these words on your external exam, and if you saw the word bursary, you'd never come across it before, you might become a little bit anxious. So that's what it means. Now, superannuation can also be set up for people at retirement to pay you a pension. And what that means is you've been saving into this annuity, superannuation, throughout your entire career. Your employer's been putting in the 9.5% that they're required to by law. You might have been topping that up as a form of saving over the time. And then when you get to a certain age, you're no longer going to be working, so you're not going to be adding to that annuity anymore. However, you can set up your superannuation at that point when you've got maybe $1 million or $2 million accrued, and you can allow that then to pay you a perpetuity in your retirement so that you've got an income to live on. And the idea is that your capital base, that money that you'd saved up over your working career, isn't going to reduce. It will stay the same, and it just pays you off the interest that that investment earns. So here's the formula you're going to be familiar with, and it's not on the QCAA formula sheet, so you do need to memorize this formula. A, which is the amount that you've invested for that indefinite period of time, is equal to M, which is the regular payment it's going to pay you, divided by I, the interest rate per period. So once again, I is going to be a decimal, and it is going to be per period because you may have compounding that takes place in different periods of time. So here's our first worked example. A business wanted to set up a bursary fund to help an Indigenous student to attend university. They want the student to receive $500 a month, and they need to find a bank who's going to offer them 4% per annum. How much should they invest to be able to guarantee that this student is going to get $500 a month? Well, step one is always going to be write your formula. Step two will be to state your variables. The variable M is the $500 a month that the student will receive, and the interest rate is the annual interest rate of 4% changed into a decimal, 0.04, and then we divide that by 12 because there'll be 12 monthly payments. So we've got an interest rate of 0.0033. We're now substituting that into the formula. A equals 500 divided by 0.0033. Now, because we're dividing by a very small number, we're going to be getting a larger answer, and that's what we would be expecting. The amount that we're going to invest is going to be much bigger than the amount that's paying out every month. That would be logical. So it's always a good idea to assess the logic of what you're doing with your formula. And we've evaluated that on our calculator now, and we have to invest $150,000. Now, obviously, you'll be writing a statement as well, because you aren't asked in the question where to find A. You're asked to find out how much should they invest, but we've run out of room on this slide for that particular step, but don't forget that step. It's very important. Okay, let's look at another example. Mixed Pies wants to set up a scholarship and has $100,000 to invest. How much will be paid to the recipient daily if the rate is 3.5% per annum? Right, so first of all, we're going to write the formula again, and there's no need to memorize the formula in 3 different ways with each variable as the subject of the formula. You can just use one formula and just manipulate that and transpose your algebra. Step 2, state our variables. A is the amount that's going to be invested, and I is our interest rate. Now we have to convert that to a daily rate. I haven't done that here on the slide because it's a very, very small number, and I'm going to evaluate that on my calculator. Step 3, we're going to substitute that into the formula. You can see it was a very teeny weeny number, and then because it's on the denominator of the fraction and we want m to be all by itself, we're going to multiply both sides by that teeny weeny number, and we'll find that m is equal to $9.59 per day. And unfortunately, I've written A is $9.59 per day. Don't worry about that. It should be M, the amount that's paid, and that's why it's always good to write your statement at the end. So basically, mixed pies can probably allow this recipient of their investment to go and buy themselves a cup of coffee or two per day, or hopefully some stationery. Worked example 3. A wealthy lady passes away and leaves her fortune of $5 million to be paid in perpetuity to the YMCA. What annual interest rate will her solicitor need to invest this money at to pay $2,500 a month? So once again, I'm going to write the formula. I'm going to substitute my variables in. I've got a variable of A, my amount that's invested, $5 million, and M is that monthly repayment that that person is going to be receiving, $2,500. It's quite generous. Substitute that into the formula. Now this time, the variable I is on the denominator as always, because that's where it is in the formula, but I need to get it all by itself. So at the moment, I'm going to multiply both sides of the equation by I. This is transposing our formula. Now, I still haven't solved for I yet. Now I've got 5 million I equals 2,500. So I need to divide both sides by 5 million. And now I end up with an interest rate of 0.05% per month. Now, I need to change that into an annual interest rate as per the question. So I'm going to multiply that by 12, and I end up with 0.6% per annum. So it shouldn't be too hard for this wealthy lady's fortune to find a bank that will offer that kind of rate. In fact, I think that will probably end up paying the YMCA a lot more money than that, because that's not a very high interest rate at all. Well, that's all we have time for now. I hope you've enjoyed this series, and please do join me for any future series. Please like and subscribe to the channel. It's been great having you today. Thank you.